Hey there, my friends. Today we are going to do a video lesson on science, specifically two forms of energy. All right. So, in our last lesson, you learned all about potential energy, kinetic energy. Okay. Potential energy at rest, kinetic energy in motion. All right. Today we're going to focus, okay? So energy is either potential or kinetic. So now we're going to talk about the different types of energy, okay? So the different ways that energy can be shown. All right? So, first we're going to talk about mechanical energy. All right? So, with mechanical energy, every moving object has mechanical energy, okay? So, for example, like a hammer that's moving to drive in that nail, all right? A leaf falling from a tree, okay? So, any object that is moving can cause another object to move, which is mechanical energy, okay? So, mechanical energy is energy that moves around by pulling, pushing, twisting, turning, and throwing. All right. So, moving hammer. All right. We're going back to that moving hammer. So, when the hammer is moving down and it hits the nail, it has mechanical energy. Okay. The energy from the hammer, the mechanical energy, is pushing that nail or moving that nail into the wood. Okay. In that push motion. All right. Now, if you've ever hammered a nail, or maybe a parent has, or someone you know, and they're like, oh, it's crooked, or it went in the wrong spot, and they have to pull it out. That hammer is also doing mechanical energy. It's doing that pulling motion and getting the nail to move. All right? So basically, mechanical energy is a combination of potential and kinetic, okay, that something has. All right? So it's the energy that we have to physically move things, okay? It's energy we move to physically move things. That's mechanical energy, okay? When I move my chair back and forth, let's see, where's my chair? There's my chair, okay? So when I move it, and I go back and forth, okay, that is mechanical energy. I am using mechanical energy. I am taking the energy from, where's my feet? Okay, feet to push my chair and pull my chair. All right? Mechanical energy. So we're going to look around my room and see where else we've got some mechanical energy. Okay, we said it's a push, a pull, a twist, a turn, and a throw. Okay. Oh, I've been sitting too long. All right. So let's see here how I can do this. Oh. Of course, my dog's up and moving. A twist turn. All right. Here we go. Door handle. Twisting. Turning. Okay. Mechanical energy. All right. Mechanical energy. I am pulling on the drawer. So I'm using my energy, all right, to transfer to get something to move. Mechanical energy. All right. I know. Let's look. We're still looking around. What else? Mechanical twisting, turning. All right. Let's see. Mechanical energy to unlock. Okay, I am using the energy in my hands, all right, to unlock and get this to move, all right? Mechanical energy. Let's see what else I can find. Those were pretty good examples of mechanical energy. Okay. Here's one. Okay. This is a push in order. Okay, I'm using the energy of my thumb to get that to move, to turn on and off my light. Now, we kind of have an idea, or hopefully we have a really good idea of mechanical energy. That push, pull, twist, turn, toss. Okay? Mechanical energy. Right now, the ball is at rest, potential. Okay? Kinetic, as it's moving. But I used mechanical energy to get it to move. That's why mechanical energy is a combination of potential and kinetic. Potential right before I throw it. Kinetic when I throw it. Okay? Potential. Kinetic. Mechanical energy. Okay? That energy that gets something to move. All right? Now, the next type of energy we're going to talk about is probably one you use all the time. Electrical energy. Meaning energy that comes from electricity. Of course, we've got things in my house. All right? We know electrical energy is going to come from one of these. That's right. It's stored up in there, right? It's waiting, okay? Potential. That potential electric energy is just sitting there until I decide to plug something into it, right? Let's see what else we can find as I move around my room. Hopefully you're not getting dizzy. All right, let's see here. I've got buried down here. There it is. All right, here we go. Hopefully you can see it. Okay. All those plugs. It's taking, let's see if we can trace the one. All right, so right there, it's plugged in. Electrical. All that electrical energy is flowing, okay, through the wires, all right, into my computer. There it is. Somewhere. Is it here? No, it's over here. There it is. Electrical energy. Notice the green light. I'm using electrical energy. I'm not anymore. So now it's just kind of potential. All that energy is sitting in here. Just waiting. Electrical energy. Whoop. There it goes. Now I'm using it. Electrical energy. All right? Now, houses, okay? Everything, a lot of things you use have electrical energy. Usually, it's in the form of wires. And if you noticed, when I went around my room a little bit, okay, I didn't have the electrical wires sticking out. No, I didn't. Okay? I had plugs and things, right? Well, let's go on a journey. I bet I can carefully show you what it looks like. Please do not do this at your house. Okay? Okay. Don't do it. Don't do it. All right. We're going to go to an unknown spot. Here we go. Of course, my dogs are going to follow me. And my children don't know I'm still recording, but that's okay. So, electrical. All right? I use mechanical energy to turn on the electricity. Okay, so I'm going to try and be very careful. Okay, but that's a circuit box in there. Okay, within that are wires. Okay, little red, black, maybe blue wires. Okay, that's electricity. Thank goodness we don't have. Jillian's looking at me like I've lost my head. Thank goodness we don't have access to those wires. Electricians do, okay? So, hold on, I gotta get my dog. Come on. So, if you were able to see those wires, That'd be a big safety issue, okay? So if you ever see exposed wires, they're little thin wires. They look like, either green, blue, many different colors. Do not touch them, okay? So anyway, all those wires are sitting in that metal box that I showed you, all right? And they're hooked up almost like you could hook up to a battery, all right? And it makes an electrical circuit, okay? And we'll talk more about electrical circuits. And when the electrical circuit is open, that means it's being used. The electricity is being used. So when I turned on the light, the electrical circuit was open. That's how all the electricity, okay, and the electrical energy got to the light bulb to turn it on. Then when I turned the switch off, I stopped, okay, the movement of the electricity. Okay, so it didn't get there, which means the light went off. It was no longer being powered. Okay, so that's how kind of the electrical currents work. Okay, and if you ever happen to see wires, don't touch them. You're going to notice they've got like a coating on them. Well, that coating is plastic because we want to insulate those wires. So when we're dealing with electricity and the transfer of energy, we bring in a whole nother set of things called insulators and conductors. Okay? You're probably like, okay, so now we've got potential and kinetic, Mrs. Chilcote. Now we've got mechanical and electrical. And now you're talking insulator, conductor. Yes. Yes, I am, because energy is huge. All right. So an insulator, insulate, keeps it wrapped up. Okay. So if you insulate something, you're kind of keeping the energy kind of close in. All right. Insulator, keeping the energy close in. You're not allowing it to go all crazy everywhere. So an insulator is going to keep that energy close. If you have an attic, you're going to have insulation in your attic. I wonder if I can see. No, you probably can't see. I'm thinking, let me show you up in my attic. That's all the way downstairs. And then I go upstairs. But it's got insulation, which is kind of like this cloud looking stuff. What that does is it keeps your home cold in the summertime and warm in the wintertime. So when the heat rises in the winter, it's not getting through that insulator. Okay. The insulator's like, no. You need to stay. So an insulator does not allow heat energy, okay, or electrical energy, all right, to go beyond the insulator. So when you wrap, okay, just like a pencil, all right? So if my electrical wire is the lead in a pencil, notice how the pencil's kind of wrapped? That's what insulator does. It only allows the electricity to come out through that point. But I can touch the rest of it and be okay and be safe because it's insulated, okay? Same thing if this had heat. Let's just say this were a flame flying through. I know it's not a flame. But if that is, say, a laser beam or something that's very hot if you touch it, if it's got the insulation around it, I can touch it and be okay. Can't touch the actual beam because it's not insulated, okay? Now, insulators are usually wood and plastic, all right? Conductors are the opposite of insulators, okay? So just like you might have heard the word conductor for somebody who conducts music, Miss Miller is the conductor of the band. Sometimes when Miss Schroyer or Mrs. Brown might stand up there for chorus or whatever, and they're leading you, they're a conductor. They're getting the music where it needs to go. It's spreading the music everywhere. Well, that's what a conductor does. A conductor increases how that energy goes, okay? For example, heat. If you were to leave a wooden spoon in a pan of boiling water, don't try this, okay? It would be okay. But if you were to leave a metal spoon in the boiling water, that metal spoon would get as hot as the water because metal is a conductor. It draws the energy, whereas an insulator repels it. No, you can't go. But a conductor is like, yes, come to me, energy, okay? So, metals, all right, are conductors, anything metal. So if on a sunny day, you are looking at 2 slides at the park, you're like, oh, yes, and you're wearing shorts and a tank top because it's hot, and you're like, yes, we got this. I'm going on the slide. Well, if those slides have been sitting in the sun, absorbing the sun's heat, that metal, which is a conductor, is going to have all that heat sitting in it. So if you happen to sit down on it, it's going to be hot. Okay? You know how sometimes you'll grab onto like playground equipment that's been out there in the sun if it's metal and you're like, what? That's because metal is a conductor. It's absorbing all of that energy. All right? But if you were to go down the plastic slide, it might be a little warm, but it's not going to be as hot because plastic is an insulator. It's keeping the heat on one side. It's like, nope, no, you're not getting to this. So those are our conductors and insulators. So if you want to make sure that your electricity is flowing really nicely, you would use a conductor, okay? A conductor keeps it flowing. You might put insulator around it to direct the control of it, but there are pluses for having conductors. Certain things need conductors to keep that energy going, and certain things need insulators to kind of put that brake on it and say, hold up. All right? So, after my video, you're going to watch another video, and it's all about conductors and insulators. Now, I'm going to forewarn you, okay? You might think it's a silly video, okay? Especially when he goes, oh, that's hot, all right? But the reason why I always watch this video is because it's such a great example of how conductors and how insulators work and what they are, okay? So, you can giggle and everything, but I want you to listen to what they're saying. The 2 kid cartoon characters are saying in the video, because it's really, really good on that, all right? And then, of course, excuse me, you're going to do your homework or your assignment, classwork, homework, whatever you want to call it, all right? And that, all assignments are due by Friday night, okay? I grade them Saturday afternoon, so you could maybe sneak some in Saturday morning, all right? But try and get them done. All right, I am always available to you every Monday, Tuesday, Wednesday, Thursday, Friday between 2:30 and 3. Just find one of the old Zoom links, okay, that's on Google Classroom. They're all the same, okay? Just click on one of them, and I'll be there. You might see a picture of a narwhal, so you would just need to say, Miss Chilcote, I'm here, because I am listening, all right? So, mechanical energy, all right? Mechanical energy, push, pull, twist, turn, throw, okay? Any object that is moving to cause another object to move. A lot of our mechanical energy is ourselves. Riding a bike, you're pushing on the pedal. So you're putting your energy into the pedal to get the pedal to go down, which then transfers the energy through that chain link around your pedal to move your tire. That whole bicycle thing is mechanical energy. You are not powering it by electricity. or heat or sound or anything else. It's all based on that initial pushing down of your energy in your foot, mechanical energy. All right. Same thing with the hammer. It's coming from you. All right. And then, of course, electrical energy. All right. We have our circuits. Okay. And when you turn off the circuit, okay, you're stopping the flow of energy. When you open the circuit, you're allowing that energy to flow. Okay. So we've got, our outlets and all of that. All right. Conductors, insulators. Insulators kind of protect and stop the movement or control the movement of the energy. And conductors allow it to flow more freely. All right. Thanks for hanging in there with me in my craziness. All righty. So have an awesome day. Have an awesome rest of the week. See ya.